In this video, we're going to look at basic number notation and different symbols that you should hopefully have come across and some you may not have. Let's start with basic notation. You should be used to the basic operators: plus, minus, times and divide. Plus and minus don't tend to change. A minus can be thought of as adding a negative number. So if we had like 2 plus 3, we could have 5 take away 2, which could be the same as 5 plus minus 2. The brackets are there to identify what's being taken away. They're straightforward. Times you're used to seeing in the format. So if I did 2 times 3. Now you will find the more maths you do, the less you see of this. Mathematicians recognise that that looks too much like an X, or if you're writing it a lot, it can morph into a plus. So we tend to not use the times sign for times. So what do we use? Well, that depends on where in the world you are and what type of keyboard you're using. If you're using a standard UK keyboard, you will discover that there is a sign on it that's an asterisk. That is used to be the multiplication sign. So if you look on the number keyboard part of your keyboard, you'll see the asterisks for your times. If you're looking at textbooks that have come from America, you'll see it as a big circle, a big filled in circle. We don't tend to use that because it looks a little bit too much like a decimal point, and it's not. This symbol I'll come to in a minute. Right. So these are your other options for multiplication, but the one that comes up most is a bracket. Anything outside a bracket multiplies everything inside the bracket. So the easiest way to denote that you've got a multiplication going on is to put a bracket. Okay. Right, the next one, so I'll leave that, sorry, times 3 there. The next one I've got there is division. We don't tend to use the divide sign very much in maths. So it did 4 divided by 2. What we tend to do is write it as a fraction. So that's the same as saying 4 over 2. Another way you may have seen it at school would be to write it in this format for working out your answer. Very few mathematicians use this format. We tend to prefer this one. But when we're writing it as part of a sum, this is the one you want to use. So when we're using this, we're using it to describe things to other people who are more lay terms, because it can lead to confusion. This format has no confusion attached to it. Okay. When you see things on Facebook that say things like they'll do 3 times 4 divided by 5 and times 2. What is that telling us to do? The times bit's easy. We've got a 3 times 4 going on, so we know they're multiplying. But what's dividing? Is it just this bit, or is it the full thing? It's unclear, and it makes a big difference. And if you play about with the numbers in the worksheet, you'll discover the difference. So I'm not going to spoil that joy for you. If you already understand, don't worry. So they're your basic operators. Right. The next ones we're going to have a look at are our equals sign You should all know equals. We also have, it's not often used, counterpart, not equals. The more maths you do, the more you use that. We've got our approximately equals. So that's when you've rounded a number, when you've taken it to something that's almost the same, but not quite. And that can also show up in a couple of other formats. That can look like that. And again, you can have the not approximate and not approximately equal to. Because that's approximately and that's approximately equals. It's interchangeable language, and depending on what textbook and what era, you'll find different usages as you go through. Oh, bear with me. Cat attack. Right. So there are equals. Let's move quickly on to our inequalities. We're going to do quite a lot of work with inequalities, especially those who do the Nat 5 maths course rather than the applications course, because they are quite a big part of it. But both courses will have inequalities. We have got this symbol and this symbol. The thing to remember with these, you always have a number or a letter before or after. So if I have A and B, I have got A is smaller than B. So that one is our less than. And if I have this one, I have got A is bigger than B. So this is our greater than. And the way to remember it is it points to the smallest one. So the one with the point nearest it is the small one. And again, we also have the is not. But we also have one more variation on these. Okay. We have got less than or equal to. And we have greater than or equal to. Okay. Now, the difference in these would be, for example, in this first one, if I had some value A is less than 3, then it could be, that is not a very good bracket. I'm trying to draw a curly bracket there. It could be 0, 1, 2, could be -4, but it cannot be 3. If I had A is less than or equal to 3, then it could be 0, 1, 2, or 3. It could also still be -4. This is set symbology. It used to be part of the old O grades and GCSEs and standard grades, but it's not part of the Nat 5, so I wouldn't worry about it. I'm introducing it for the sake of I'm showing you general notation. So I'm not going to go into depth about what it means, but if it's in curly brackets, generally it's denoting a set, a grouping of something. Right, so that's our inequalities. We will do quite a lot of work on them in the coming weeks. But that's your basics. That's what an inequality looks like. Some of the other ones you might be used to. We've got pi, the Greek symbol, and that has a set value in maths. It's absolutely equal. So that's 3 lines. It's absolutely equal. There is no deviation. It is 3.14159, and it goes on forevermore. Now, if you see 3 dots at the end of a number, In maths, that means and so on. It means it continues, but it gets to ridiculous numbers. So we're not going to go into them. So it's like, there is more, but we don't care. Another one you might have come across with, if you have used Excel a lot, is sigma. Sigma means add them up. Or sum of. Okay. Another one you might have come across, there's a lot we can do with sigma, and the more maths you get into, the more you see there's more you can do with it. But the general is, it just means add up. Another one you might have come across, if you have done anything with angles, is theta. Now, if you've ever done any Greek, you'll have recognised that these are all Greek letters. A lot of our geometry comes from Greece, so a lot of the words and symbols that come with that have come with Greek origins, and Greek words have followed through. Theta tends to be used for angles, but not always. It just means an unknown. It's very similar to algebra, but you tend to find it used a lot in angles to mean the missing angle. If you've done a lot of work with medicine, you might have come across delta, which can show up in any of these forms. And again, it's just denoting another variable. It's just some more algebra for you. It's not used in Nat 5 very often. I don't think I've ever seen it in an exam paper. I have seen it in a couple of textbooks, but they're obscure ones, not the ones that you're going to be coming across in class. I just don't want you seeing it and thinking, oh my God, what does that mean? Is this some strange thing? No, it's just another Greek letter we've stolen, so we've got another one to add to the 26 we normally use. Very occasionally you will see I used as a meaning of its own, and that is known as the complex number. And I am not going to go into its meaning. It is not a Nat 5 level. Usually when you see I, it's just going to mean the letter I. It's not going to mean anything else. The complex number, you're looking at quite high level maths. I wouldn't expect you to see it before the degree level. So I'm going to leave that one. Right. What else might you see? Well, one you might have seen in the real world is the infinity symbol. And I did not do that very well, did I? It looks like a Mobius strip. So those of you who are into your puzzles will know a Mobius strip. This is infinity. There are definitions of infinity. Probably the easiest one is to think of it as an unlimited number, endless and forever. Think of the biggest number you could ever think of, add one more, you're still looking for infinity. You can also have minus infinity. A lot of the symbols you'll see online for infinity have the two sides the same size. Historically, that's not accurate. The left one should be a smaller circle, a smaller loop than the right loop. There are three main types of infinity. There's the mathematical, the physical, and the metaphysical. We will only be dealing with the mathematical, and it is not part of the Nat 5 exams. This is purely just for interest. The only time you'll come across this is when we look at trigonometry at the end of the Nat 5 maths course. If you do the applications of maths course, we won't be covering it at all, and we won't be looking at it in depth. We will purely be mentioning it in relation to tangent graphs. And that is where I'm going to leave this one on notation. There are other notations we will come across, but these are the main ones that you need to have some familiarity with. Okay, thanks.